Good afternoon, everyone. This is Elisa Baum. I'm GridGain Systems Director of Product Marketing. We'll begin in just a moment. I just need to conduct a little bit of housekeeping before we get started. First, could you please raise your hand using the hand icon located in the GoToWebinar control panel to let me know if you can hear me? And let's see. Yep, I see hands. Thank you so much, audience. Next, during this webinar, you will be on mute. Should you have any questions during the discussion, please enter them in the questions field within the control panel. At the end of the webinar, we'll take time to answer as many questions as we have time left, and those that aren't addressed will be answered in a follow-up blog entry on GridGain Systems blog. In addition, a recording of this webinar will be made available to everyone within 48 hours, and I'll also send the slide deck. Would like to thank you for attending today's webinar, the GridGain in-memory computing platform, a deep dive on the data grid. It's being jointly presented today by Rachel Pedreschi. She's GridGain Systems Director of Solutions Architecture, and Matt Sarrel. He is our Director of Technical Marketing. And with that said, I will go ahead and turn the floor over to the team. Go ahead.
All right, good morning. Thank you very much for introducing us, Elisa. Good morning, Rachel. I'm going to just keep talking as if I'm not the only person here because I know there are other people here. Today we're going to talk about data grid, which is sort of the, I don't know, in some ways it could be the most important component of our in-memory computing platform at GridGain. And so we thought it was a good idea to have a webinar about it. Here's our agenda. We're going to do a brief introduction, and that will include a discussion of what is in-memory computing, and then go into an overview of the solutions. I have a nice survey that talks about who our customers are and how they're using the product, and then deep dive into data grid, which will be Rachel's part, and we'll finish up with some customer case studies that show how our customers are using data grid as a component of the larger platform in general. All right, so why the time is right for in-memory computing. We've got everything is becoming more and more digital. And there's also, in addition to everything now being digital, there are needs for us to have real-time access to information and to be able to conduct real-time analytics on this information. And at the same time, we've got web scale applications that are, just no one could have imagined years ago that you would write an application and have hundreds of thousands or millions of concurrent users. That's what we're seeing today on both on web scale, or even if you look at business applications, because at some point they also become web scale. And we're dealing with greater and greater amounts of data in our daily lives, and this is about to really take off with the growth of the Internet of Things, which will generate huge amounts of data, and businesses as well as individuals will require real-time analysis for real-world uses. And at the same time that we're starting to see more and more data being used by more and more people concurrently, the cost of memory is coming down. And that's important because basically the technology to build databases and computing platforms in memory isn't really new. But what's new is the combination of that technology and declining memory prices. So if you look at this chart, we see that we've got more and more data, and DRAM prices are coming down about 30% a year. It's kind of interesting. I recently did a calculation where figured out that if you had a terabyte in memory, which would not be so unusual at this point. Lots of our customers have a terabyte in memory on a single server, even. That would have been over $30 million in 1985. So you can see the combination of the technology being available, the decreasing cost of memory, and the growth in data all sort of add up to form this perfect opportunity for in-memory computing. And we can see that.
And Matt,
yes.
I just want to mention too, we also have some new types of memory coming out, right? So phase change and other types of even non-volatile memory that is being released by Intel and Micron. There's a lot of buzz around that that's going to be able to increase the footprint for a lot less money on some of the new servers coming out, and also make it non-volatile. So I think that's some interesting changes in the memory market too.
Yeah, that'll go a long way towards doing more in memory by having it be non-volatile, meaning that like you could lose power and you restart, and you don't have to then bring everything off disk into memory in order to work with it. So this is likely to increase adoption of in-memory technologies, which goes hand in hand with this beautiful Gartner chart that I have, where basically we're talking about in-memory enabled infrastructure being $10 billion by the end of 2019, with a pretty steady growth rate to get there. And you can see the way that Gartner breaks this up. They talk about in-memory application servers, messaging infrastructures, event stream processing, in-memory data grids, et cetera, et cetera. And that's all interesting. What we have at GridGain and Apache Ignite is an in-memory computing platform, which is a multi-featured solution. It's a data grid, compute grid, in-memory SQL grid, streaming grid, service grid, stuff like that. So it's not just a single, in-memory product. It's a group of in-memory components that are tightly integrated. One thing that we do is we slide between an existing application and a data layer, which is something that Rachel will talk about in more detail, and provide support for a variety of use cases, including transactions and analytics. When we do transactions, they can be ACID compliant, and we support a good deal of different platforms like RDBMSs or NoSQL or Hadoop, and we offer a unified API with support for a wide range of languages for your applications to work with the computing platform. And it can also be deployed anywhere, on-premise, in the cloud, or in a hybrid environment. Looking at the Apache Ignite project, right? So GridGain is the commercial version of Apache Ignite, except with a little twist, which is that Ignite started as the community edition of GridGain. And after about 7 years, it was already a reasonably mature product, and GridGain donated Ignite to the Apache Software Foundation. And so now what we're about 3 years later, we've seen Ignite grow to be the second fastest project to graduate after Spark. We've got 60 plus contributors, and it's still growing. And we've got a lot of momentum. And again, we're dealing with a mature code base, 1 million plus lines of code. And now I think I'll turn this over to Rachel to explain how it all works.
Thanks, Matt. Oh. So I wanted to add a little bit to what you were saying earlier. You had some pretty cool information there about Gartner. There is a quote from Gartner saying that memory is the new disk, and disk is the new tape. Tape is the memory is the new disk, and so that's where puts Apache Ignite and GridGain in this sweet spot, where if you are going to be creating an application that is cloud ready, that is going to give your customers the best possible experience, it's going to have to be memory based. And the economics of different types of memory, including DRAM and some of the new ones out there, really make this actually feasible. And from my perspective, I've been building data architectures for nearly 20 years now. Why build an architecture based on a product that was designed for legacy technology? So the databases and even the NoSQL systems out there were designed to run off disk. If you're going to be creating an application that you don't want to have to rewrite in 5 years, build it off of a memory focused architecture, which is exactly what GridGain and Ignite offer you. So we're going to talk a little bit about how that architecture works and what are the features and benefits that you get with using Apache Ignite from GridGain. So traditionally, if you build an application, it is going to talk to a database of some sort. This is a fairly well-worn path out there. And where Ignite and GridGain fit is in between your application and your database. Specifically for the data grid portion. We do have another portion of the product called Compute Grid, which you can see in some other webinars from gridgain.com. But today we're going to be talking about data grid. So Ignite actually sits between your application and your system of record. And it's there to provide various values. So can you click the next button, Matt? First off, it's in memory. We've talked a lot about this so far, but there's two ways that it can be in memory. It can either be in Ignite and through a key value storage mechanism, or it can be in the Ignite file system, which is an HDFS compliant file system. It also allows for indexes in memory, and every data structure will actually live in the memory portion of Ignite. When you create a distributed system, though, you do raise the level of likeliness that something's going to happen. So if you have 5 machines in total in a distributed cache, there's a chance that one of them is going to have a network problem or a disk failure. Chickens and toddlers let loose in the data center. Who knows what happens? So Ignite was designed to be always available. So there is redundancy actually built into the system to maintain, all the nines of availability required for a modern application. So not only are you getting in memory, but you're also getting the continuous availability guarantees of modern distributed systems. Also, distributed systems provide extreme scalability. And in the case of Ignite and GridGain, this is linear scale. So as you add more nodes to your cluster, you get more and more data available in your cache or in your data grid. But you don't have to give up some of the things you're already used to working with a relational database. So if you're used to working with SMP systems or relational databases, you may not want to move to a NoSQL system because you want to be able to use SQL, or you can't give up any consistency guarantees and you need ACID level consistencies, or you're using a Hadoop platform and you want to be able to use MapReduce. So Ignite and GridGain provide you all those standards So your application can speak SQL 99, it can do ACID transactions, it can do MapReduce. All your standards are still there. You don't have to give those up in order to have a scalable, continuously available, key value in memory architecture. And if you are already using a NoSQL system like Cassandra or Mongo, and you're missing some of those features like strong consistency or the access through SQL, if the data goes into the grid, in your data grid, it will be accessible through your application through standard SQL. So it makes using Cassandra or Mongo a lot easier for your downstream users. So you can get developed quickly, you can get all the guarantees from a NoSQL system, but you also can make sure that your users and your developers have a standards-based system to use. Also, there's no rip and replace here. So because Ignite and GridGain will move between, slides in between your application and your existing database, you don't necessarily have to write your entire code to go to a new system. So for example, if you were going to be moving from Oracle to Cassandra, you would have to rewrite your application and your entire data store and your schema in order to fit this NoSQL system. In the case of Ignite, you can just put Ignite between the application and the database. You don't have to change your databases, and your application will just speak to Ignite. And it does that through a number of APIs or through ODBC and JDBC. So there's no need to move your underlying data store. Last but not least, we also can help accelerate and provide data, a data grid application for Hadoop. I'm not sure how many people out there are familiar with Hadoop, but its mascot is not a jackrabbit. It is not known to be a fast system. So this gives an in-memory layer either through a file system or a key value store that will cache the data that lives in Hadoop. And what goes along with that is a Spark as well. So if you do have a Spark application that is already in memory, but you want to create that entire data pipeline in memory, you can do it through Ignite. So the data gets moved out of Hadoop or out of your system of record into Ignite or GridGain in the data grid or in the cache, and then your Spark application can do its in-memory magic on top of that data. So how are all these pieces put together, and how does Ignite and GridGain fit? So today's topic is we're going to be focusing on data grid. Data grid is a fundamental portion of the Apache Ignite project. It also includes a compute grid as well. And on top of the data grid or the compute grid, there are a number of different applications that Apache Ignite provides APIs for in order to do a number of different in-memory things. Pretty much anything you want to do in memory is available there. So there is OLTP caching, OLAP caching, again through full SQL 99, full joins, distributed joins, aggregates. We like to call this the SQL grid. The SQL grid works off of the data grid and provides you full SQL access. Grid as a service, or GaaS, that's my term. And that allows you to deploy a data grid and compute grid application for everyone in your organization. We have a number of clients, including Spearbank, that are deploying this on thousands of servers, wrapping a lightweight API layer and allowing all their application developers to do all their work in memory and only have a single platform to manage. We support, Apache Ignite supports all the modern streaming applications, including Kafka. There's not a day that goes by that I don't talk to somebody about how Kafka works with Ignite. But that includes RabbitMQ, RocketMQ. We also even have our own streaming APIs if you don't necessarily need to use those additional products. But these will all work off of the data grid in order to create a incredibly powerful in-memory distributed cache for your application. So this is Apache Ignite, and we also, GridGain does provide support services and indemnification for Apache Ignite in a product called GridGain Professional. they are the same code. You are using all the same features that Ignite offers, but are packaged up in order to be tested and to be patched, under whatever SLA you require. GridGain Enterprise is built on Apache Ignite, built on GridGain Professional, but has a few plugins that provide advanced functionality for your data grid in the enterprise. And that includes security with LDAP, Kerberos, JAS integrations, extreme high availability for multi-data center replication. So you can actually replicate up to 32 different data centers, either in active-active or active-passive mode. We're going to be talking about this a little bit later. And a monitoring and management tool called Web Console that will give you immediate insight into the health of your cluster, how your data grid or your cache is behaving, and general management of capabilities. If you want to test drive that, that's also available on the GridGain's website, and you can test drive the management console called Web Console. So that's how the products, that's how GridGain and Ignite relate to each other. Matt, would you want to talk to us a little bit about who's using this?
Sure, I would. Thank you, Rachel. That was great. So we put out a survey of our users, and I'm going to run through that survey to give everyone a good idea of who's using GridGain and Ignite and what they're using it for. So if we just, there's not a tremendous surprise here that software is a big use for our in-memory computing platform, followed by banking and IT consulting. You could see this whole list. I don't have to read it to everyone. So, there's a lot of financial, investment management, insurance, fintech. That's a big use case, as well as e-commerce and retail. But pretty much, you have a lot of data and you need to work with it very quickly. It sort of doesn't matter what industry you're in. It's just nice to know who's already come to us and benefited from the extreme performance and scalability that we offer. And so, what uses were you considering? So, database caching, application scaling, high-speed transactions, real-time streaming, fast reporting, which is an analytics, scaling the database, which is pretty close to database caching, building a hybrid transaction and analytical platform, speeding up Spark, web session clustering, Hadoop and MongoDB acceleration are on that list. But you can see we've got database caching. I mean, if you look at the top three, these are directly related to data grid, which is what we're talking about today. And then it comes as no surprise that rating what's important, data grid is at the top, followed by compute grid, in-memory file system, and other features. ANSI SQL 99 compliance is important, and container support is important, and I believe that's growing in importance as more and more people start using containers. And then where do you run GridGain or Apache Ignite? Private cloud, on-premise, AWS, Azure. We're in the AWS and Azure marketplaces. Basically, you can run GridGain and Ignite anywhere you want to run it. People are using Java. They're using SQL, MapReduce, .NET, C++, Scala, Node.js, PHP, and Groovy. But you can see far and away, Java and SQL are the most popular languages that are used to access data in GridGain and Ignite.
Luckily, those are some of the two most commonly used APIs for the data grid, which we'll be talking about in a little bit. So, hey, pretty useful there.
Yes. Okay. And which data stores are people using? Again, this probably has a lot to do with just data stores in general, right? So people are using Oracle, they're using MySQL, HDFS, a variety of so you see a variety of NoSQL and relational databases that are in use. Okay, so now that we've talked about these like broad descriptions of how one would use data grid, I will turn this back to Rachel for more detailed information about how someone would use data grid.
Sure. So you can think of, for those who are not 100% familiar with what a data grid is, you can also think of it as a distributed cache. There's subtleties on both sides, but personally, I went through a long time, had heard about database caching as a DBA, but hadn't really heard about what a quote-unquote a data grid is. But I think that term is very common in financial services applications and in other industries. But either way, it's either a data grid or a distributed cache. There are two modes that you can create your cache in. You can either replicate your data, which means that all the data in that particular cache, and in the most cases, a cache can be equivalent to a table. That cache or that table will be duplicated on every single node of your cluster. That is called a replicated cache. This is mostly used for read-heavy type of data, or lookup tables or dimension tables if you're going to be speaking star schema. And it makes sense, right? So you don't necessarily have to be moving the data around a lot. Instead, it exists on every one of your nodes. But it doesn't really make sense for big data sets because that could get kind of expensive fairly quickly. So we offer the other option, which is a partitioned cache. And you could also think of this as sharded, but it is transparently sharded, and it takes a subset of the data and distributes it out to each node in the cluster. You can then determine how many backup copies you want in order to maintain availability. So you might have one primary copy of the data. So 1/5 of your data on one of your 5 nodes, and then maybe 2 backup copies, and those will live on different nodes. These can also be written to be rack aware, so you can make sure that if you lose power to a rack, or again, my very favorite, chickens and toddlers take over your data center, that you will maintain availability. So 2 different types of cache modes, and this provides for horizontal scaling. So as you add more nodes to your cluster, you just you give yourself more room and more memory to work with.
So Rachel, when might someone choose a replicated cache over a partition cache, or vice versa?
So I mentioned earlier that a replicated cache is typically a read-heavy type of set of data that's usually smaller. So lookup data or dimension table data makes sense in a replicated cache. But if your data set is larger, you may want to partition it. So that way you are spreading out the load over your entire cluster rather than just on a single node.
Are there performance considerations for making that choice?
It depends on the type of joins you're going to be doing. So if you're going to be joining data, joins are probably the most expensive thing to do in a distributed system. And when people come to me and say, hey, what is a general rule of thumb for performance tuning a distributed system? I'm like, well, don't distribute your data. So that would be a replicated cache, right? If you have a full set of your data on a single machine and you're joining those 2 tables together, there's no need to move data over the network. Once you partition data, though, you're going to be moving data over the network. So if you're going to be, so you mitigate the performance implications and the network traffic required in a partition join if you have the other table replicated on that particular node. So that's like the second best option for if you're going to be joining data together. There, of course, is times where you're going to have to join partition tables together, and Ignite does support both correlated and non-collocated joins. Collocated joins will be where both tables are partitioned by the same key, so they'll be able to join locally, again, minimizing the network traffic. And of course, the worst case scenario would be the equivalent of a relational database cross join, where you actually don't collocate your data, and then you're going to be doing a scatter gather. So the performance implications run from no different than an SMP system to as bad as a cross join on a SMP system. So just keeping in mind how you lay out your data and what type of joins you're going to be doing is really important here. That was a very long answer to it depends.
Right, but every word of it was fascinating. So thank you.
All right, so one of the I think a really killer feature, especially for grid as a service or enterprise-wide deployments, is this concept of cluster groups. So you can actually group various nodes inside of your cluster and limit your caches to those particular nodes. And this is really helpful in multi-tenant situations where you may not want to mingle data from one client to another, or from one application to another if you're a single, if you're supporting a single customer. It also helps you define resources and tune various portions of the cluster for particular applications. So cluster groups is another feature of Apache Ignite that I think is very, very powerful in improving the performance and the usability and the multi-tenant features of Apache Ignite. So it becomes a very, very good option for rolling out for large enterprises. Next, please. So tiered memory and local store. So we were talking earlier about how the price of memory is going down and it's so much more ubiquitous and yada, yada, yada. At the end of the day, it's still expensive. It's still the most expensive form of storage out there, but it is incredibly fast, over, up to 1,000 times faster than disk access. Within RAM itself, you can actually choose to store your data on or off heap. I think in the latest version of Ignite, it's going to be defaulted to off heap. And this is pretty awesome because you're no longer fighting the GC gods when it comes to tuning your system. So the garbage collection, which creates stop the world pauses. Oops, can you go back one? Thanks. So create these stop the world pauses. So you have tiered memory, you can store your data on heap or off heap. You also have the ability to create your persistent store on disk, and that persistent store could be in a relational database, and in future releases of Apache Ignite, it actually could be within Apache Ignite itself. Or you can do a local recoverable store where it actually snapshots what's in memory onto disk. So there's a number of different modes you can use for memory for tiering your storage. Go ahead, next. So I started talking about off-heap memory. I get very excited about this because this does really make a difference when it comes to managing your cluster. What this also allows for is vertical scale of your application on a single machine. So we talked about horizontal scale, adding more machines to add capacity, but you can also add more memory to your machines because Ignite takes advantage of off-heap memory. And so you can have a small heap, a good size, maybe 8 gigs, something that's very easy to manage, and then 128. That's all off heap. And all of that is going to can be used by Ignite for storing your data. So this provides not just horizontal memory storage of a distributed system, but also vertical storage as well. Next. In GridGain Enterprise, we've added a feature to Apache Ignite that allows you to do multi-data center replication. And this will provide for, disaster recovery or for load balancing. So you can set up your different data centers in active-active or active-passive mode. You never know when a tornado is going to hit your data center in the Midwest, or a storm's going to flood your data center in Asia, or a truck's going to back into your power grid. True story.
Or the old toddlers and chickens thing.
That's right. Who's going to allow toddlers and chickens to run amok in your data center? You have to make sure the security is high enough on those. So that's what GridGain Enterprise offers on top of Apache Ignite. So you can have bidirectional replication in an eventually consistent manner. Next, please. So the external persistence is, I mentioned earlier, where you can have your, the Apache Ignite sitting on top of an existing database. So like Oracle, Matt was mentioning that, Oracle's the most commonly used one out there, SQL Server, MySQL, and a NoSQL database. And this, we provide full read and write through capabilities to the underlying persistent store. There's support for write behind, and you configure how the data moves from the persistent store, so the persistent on disk store, into memory. This is actually very, very easy to set up. You don't have to change the way your schema works. You just go through a little online wizard that's a lightweight ORM mapping, click next, 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 and it will suck in your schema into Apache Ignite, and you're pretty much done at that point. So the external persistence layer supports any database that has an ODBC or JDBC connection associated with it. And there's also an external persistent store in Apache Ignite that works with Cassandra, because Cassandra itself does not have an ODBC or JDBC connector necessarily. Next, please. So cache APIs. We were speaking earlier that Java is probably the most used language, but there's a number of other ones out there, and most of those we have an API for. So your application we speak your application's language. There are a number of different APIs available to talk to the grid itself, including ODBC and JDBC, which gives you full SQL grid capabilities there. But you can do text queries with Lucene indexes, any type of other indexes that live in memory for SQL type of queries. Very robust as far as what languages it supports. Next, please. Spoke about SQL support. It is ANSI 99. This is full SQL. It's not SQL with a K. It's not other types of form of SQL. Right. This is actually real SQL.
It's not RQL.
It's not RQL, exactly. It's not Ignite QL. It actually utilizes the H2 SQL parsing engine. So if you're familiar with that particular database, or even if you're not, it's still SQL 99. Allows you to do full joins, aggregates, group bys, no restrictions that you typically have with a NoSQL system. Next. As I mentioned earlier too, the data grid also supports full ACID transactions. And I wrote a blog post not too long ago talking about the differences between transactions. Is this a CAP database? Is this an ACID database? Is it both? And how do you tune the particular data grid to handle what type of consistency you need? And it's not an all or nothing it's not all or nothing. You don't have to say, hey, I want this to be fully consistent. I want this fully to be ASCII consistent, and I'm going to wait around for, unimportant data to be, for it to be said, hey, yeah, this is consistent. We're good. This transaction's good. Commit. Each individual transaction you submit to Apache Ignite can have a different consistency level associated with it. So it can be fully consistent, optimistic or pessimistic concurrency modes, multiple different isolation levels. There's deadlock protection, or you can have an eventually consistent transaction. Again, this is completely configurable by your application on a transaction by transaction basis. Next, please.
Okay, so would you like to give the overview of how customers are using us, or should I?
Oh, I think you should. Well, yeah, I think people have heard me ramble long enough. Let's talk about how, all right, this is all great. This is all good in theory. What are people actually using it for?
Okay. And also, I want to apologize for some of that slide switching before. My mouse has this ultra sensitive knob on the top of it that tends to switch slides. So thanks. I like to do it to keep the audience on their toes. Okay, so we have thousands of deployments of Ignite and GridGain, and these are typically used in places where you need extreme performance and scalability. So these tend to be, let's see, like where we've got automated trading systems, doing real-time analysis on positions, making high volume transactions, low latency trading, as well as also calculating market risk and exposures in real time, financial services, fraud detection, so real-time fraud detection, real-time risk analysis, insurance rating and modeling, big data analytics. We've got as well biotech and drug discovery are pretty interesting. We've got customers who are basically have databases of proteins, and they can select the proteins to add to their drugs and look for interactions and look for predicting drug efficacy, and do this much faster than they could have done it using older architectures. So if we dig a little bit deeper into how customers are using GridGain and Ignite in the retail space, we have a customer, Expertisset, and basically what they do is they have a whole bunch of brands. It's like over 650. It's probably 700 by now, which cover over 4 million products. They connect these brands with brand advocates. The brand advocates, they write reviews and they provide advice on the products. And it all sort of translates into ultimately converting sales. And so basically some of the things that are really important here are working with these enormous product catalogs and working with members and doing it all in real time. So we're looking at, or Expertisset is looking at thousands of active user sessions, providing personalized content, and then doing real-time analytics on what these brand ambassadors do. So, anytime we can get a quote from a CTO saying it's really fast and it scales really well, we're always eager to get that quote. So another customer that we have is Intelligent Pipe, and what they do is it's a very different use case around the same technology though. They're using the software to monitor telecommunications networks and mobile devices, basically with the goal of improving business and operational processes. So they're collecting and analyzing huge amounts of data on mobile networks about user traffic. So like what users are doing and the experience that they're having. They're integrating this with network utilization data, and they're not only reporting but also making predictive recommendations for customers about optimizing their networks. They use GridGain Professional Edition, and they've basically built a high performance, low latency telecom network analysis platform. And again, another great quote of, GridGain ensures responsiveness regardless of how much information we need to search through. So you can imagine they're dealing with multiple terabytes per day across multiple carriers. This is the essence of speed and scale as far as ingesting new data and analyzing that data. So what else do they? They have leveraged our unified API, and they're using our SQL support for analytics, and they've been enjoying the linear scalability of our computing platform that we offer. And so one of the things that does is it frees them to stop focusing so much on the technical aspects of the business and start focusing on the actual like revenue generating parts of the business. So they're not maintaining yesterday's code base. They have built tomorrow's code base, and they're able to use it to run their business instead of worrying about maintaining it. Another interesting customer is Cyberdust. This is actually like a very cool use of an in-memory computing platform, and especially the in-memory data grid. So what they do is they're disappearing text messages. These text messages are untraceable, encrypted, they're disappearing. This is an app available for Android and for iOS. It's Mark Cuban company. And so it turns out that if you want to build a disappearing message platform, it's really good to build it in memory, because then you just don't persist it to disk. And so they have some pretty amazing performance on their messaging infrastructure, which I mentioned somewhere. Oh, I get to it in another couple slides. But anyway, they're running GridGain Professional Edition on top of Amazon, and they've got everything in memory. And they make extensive use of our unified API because they're integrating this disappearing messaging platform into a whole bunch of different applications. But the performance they're getting is incredible, right? So they're talking about being able to send and receive 300,000 messages in 30 seconds. So that's writing them. Well, I guess not writing them. You have to do that on your own. Sending them and then disappearing them within 30 seconds. And again, we've got these quotes where they love us. And so now turning to another company that's using us, Misys. They make a financial software. It's used by 48 of the 50 world's largest banks. They're basically across the world. And they deal with huge amounts of trade and accounting data, and customers require high-speed transactions and real-time reporting. And their old infrastructure was rapidly reaching the point where it was not going to be able to cut it anymore. So they redesigned their application stack and added data lake support for reporting. And they did all of this around using GridGain. And they are running a bunch of commodity servers. Each has 256 gigs of RAM, nothing crazy. And the data is stored in memory for transactions, and they receive market data feeds, and they run some AI on that market data. And then they also use our compute grid to do parallel processing across the cluster. And so the end result is that they've built this new product called FusionFabric.cloud, which integrates with trading systems, and I just said their clients are using it all over the world. There's a whole bunch of different things that they're doing, and they have basically like completely leveraged the data grid and the compute grid. And I think we're actually approaching the very end of our webinar. I don't know, Rachel, do you have anything you'd like to add, maybe to tie everything together?
Just put me on the spot like that.
Yeah. No, you tie it together. I spit out a whole bunch of customer stuff. You tie it together.
I think you did a wonderful job. I mean, nothing speaks better than our customers. So my recommendation to anybody who wants to learn more is to go to gridgain.com, take a look at some of the other webinars that we've put out there, specifically ones on compute grid and the SQL grid. Those are related to this particular topic. If you want more information on the upcoming persistent store that's coming out with Apache Ignite, take a look at the Apache Ignite forums. There's a good conversation going on there about the possible need of not requiring a database like Oracle or Cassandra to provide all these levels of guarantee, and simplify your architecture. So get involved, even if you aren't necessarily interested in GridGain's enterprise features. We like to get people involved in our community. If you want to speak at a meetup, you want to come speak at one of our conferences, please let us know. We're happy to hear everybody's stories. Yeah,
we'd love to hear how you're using in-memory computing.
So even if it's not with Ignite.
Well, guys, we have a couple of questions from the audience, and I think we have a few minutes to take those questions. So,
great.
You guys ready?
Yes.
I'm going to throw them at you. Okay, if I am reading data from a cache from a Hadoop job that has thousands of tasks, how well does Ignite handle all of the connections from those tasks?
This sounds like a Rachel question.
It does sound like a Rachel question. Rachel was formulating an answer in her head. It's as well as you've configured it to be. Our Hadoop accelerator, take a look at that particular product that does allow you to put the entire MapReduce pipeline into memory, not just the data. And it allows you to create sort of this Ignite file system that will sit above the Hadoop file system and speed up your MapReduce jobs. How much? It really depends. And I would just take a look at it. I would say give it a shot, because honestly, the Hadoop accelerator is probably the easiest thing to install. You put it on your data nodes and you turn it on and you let it go and see how it works for you. Use the monitoring tools to see how your cache hits and misses are going, see what the performance is. And that would be my best recommendation, honestly, for how well does it perform. It performs as well as you let it, depending on the resources and the types of jobs that you have available.
Okay. I also there was a question about Apache Ignite 2.0. We're actually doing a webinar on June, I believe it's 7th. It's up on our website, and it's called Introducing Apache Ignite 2.0, and it's going to be presented by our product manager. So a lot of the details that Rachel's hinting at or talking about will be discussed there. I'm also adding a new GridGain related webinar for GridGain 8.x for the end of this month. So keep visiting our website. We're constantly updating our webinar program. Okay, any more questions from the audience? Go ahead and enter them in the questions field. Right now we don't have any others, and we are almost at the top of the hour. And yes, one question for me. Everyone will receive a link to this recording as well as links to the slides. So I will send that out within 24 hours. So you'll all get a copy of that. And feel free to share that with your coworkers and friends and family. Okay, so I don't think we have any more questions from the audience. So Rachel and Matt, thank you for a great job. Audience, thank you for attending. We hope to see you on a future show.
That's great. Thank you, everyone.